Okay, so today we're going to talk about special right triangles. The special right triangles are very, very important. I know I keep saying this stuff, but you're starting to get to a point where everything's going to start to build together. You're going to have to know your special right triangles. You're going to have to know your Pythagorean triples, and you're going to have to know that this is that and that is this. And you've seen how some of that works together in the past, but now we're just adding even more stuff for you to have memorized so that you can figure some stuff out later on. So for special right triangles, there are two of them, only two. That's good. The first one we're going to talk about is the 45, 45, 90 triangle, which has its own triple combination. So I told you about some of the Pythagorean triples on the last video. For this video, we're talking about two very special triangles. That's why they're called special right triangles. And they both have Pythagorean triples, but they are not all whole numbers. That's why we don't normally refer to them as Pythagorean triples. But since you need to have them memorized, I might as well call them that. So for this one, whenever you have a 45, 45, 90 triangle, and that's called that because that's what the angles are, this side is 1, that side is 1, this side is a square root of 2. What that means is, just like we have with our Pythagorean triples in the last section, I could take the 3, 4, 5, multiply them all by 2, and get 6, 8, and 10. And that was another Pythagorean triple. Well, for this kind of triangle, whenever you have a 45, 45, 90 triangle, it doesn't matter what this side is, because this is a 1. I can take that number, and whatever this side is, that's going to have to be what that side is. And in order for me to find this side, I multiply it by the square root of 2. It's like a little pattern you follow through with, just like we did with Pythagorean triples. That's the way we're doing with this. Only every time we follow through with it, because it's another similar triangle, they're all going to be 45, 45, 90 triangles. So it's a faster way of getting that number. Over here, for the second triangle, it's a 30, 60, 90 triangle. So it has angles of 30 degrees, 60 degrees, and 90 degrees. And there's a pattern for it as well. Its pattern is a 1 down here for the smallest side, and then a square root of 3 up here, and a 2 for the largest side. So if we were to see another triangle that was a 30, 60, 90 triangle, and this side was 5, then I'd say 5 times 1 is 5, so that's the smallest side is 5. And then the square root of 3 times 5 is 5 square roots of 3, so this side must be 5 square roots of 3. And then 2 times 5 is 10, so this side must be 10. So it works that way. It's a pattern that works every single time. But if you don't memorize the numbers and where the numbers go, then you're never going to be able to use the pattern. You have to have this stuff memorized. So in order to use the pattern and to show you how to use the pattern, we're going to do a couple of problems of each. So down here, I have my little 45, 45, 90 triangle, and I know that must be 45 degrees because that's how you get the 180. So I don't even have to label them all. But here's my triangle. This side I'm going to call A, that side I'm going to call B, and that side I'm going to call C. Kind of like Pythagorean theorem. So if they tell me that A is 12, then if I know that this is a 45, 45 triangle, then I know that this is a 1, that's a 1, and this is the square root of 2. I know that because I've memorized that. So since that's the case, if A is 12, I know that B is going to be 12 times 1, or 12. And then for C, I know that C has to be 12 times the square root of 2, or 12 square roots of 2. Outside times outside, inside times inside. So those are my other two sides. It's really quite simple if they give you one of the ones for your side. But what happens when they don't give you one of the ones for your side? Like for right here, they told me what C was. They didn't tell me what A and B are. But that's okay, because when I was doing C, I used my A to get there. So for C, we know that C has to be equal to A times the square root of 2. So up here, since that's the case, I can say C equals A times the square root of 2. So instead of writing C, I write what C is. 4 square roots of 15 is equal to A times the square root of 2. And if I'm looking for my A, just divide both sides by the square root of 2. That gives me that A is equal to 4 square roots of 15 over the square root of 2. The only problem is we are not allowed to have square roots on the bottom. So that means I'm going to have to rationalize it by multiplying the top and bottom by the square root of 2. Well, the square root of 2 times the square root of 2 on the bottom gives me the square root of 4, which is just 2. On the top, outside times outside is 4. Inside times inside is 30. Then to reduce this, 2 can go into 4. I can't put 2 into 30 because 2 is an outside number, not an inside number. If I could have divided them here, I could have done that because they're both inside numbers, but that doesn't divide, so that didn't help. So 2 goes into 4 2 times and gives me 2 square roots of 30 to be A. Since I know that A equals 2 square roots of 30, that means that B must equal 2 square roots of 30. So it can be done. All you have to do is a little bit of algebra, which is good because you already know algebra. That's handy. The same thing happens with a 30, 60, 90 triangle. And once again, I don't have to have all the angles written in because that one's 30 and this one's 90, that one has to be 60. So we know that that's the case. So if they tell me D, I know because I've memorized this side is 1, this side is 2, and this side is the square root of 3. That's how I've memorized it. I memorized them in order, 1, 2, square roots of 3, even though I didn't end on my hypotenuse, I did the numbers in order. So for this one, they tell me that D is 12, which is great, because then I can say that E is going to be 12 times the square root of 3, or 12 square roots of 3. And then F is going to be 12 times 2, or 24. Piece of cake. Well, the same thing happens over there. It's just that you won't like it over there because it's already got a square root in it. It's not a nice, pretty number. So it doesn't make it quite as simple or quite as easy. But it does the same. I mean, you do it the exact same way. You would say E is going to equal 12 square roots of 3 times the square root of 3. So E is going to be 12 times the square root of 9, which is 3. So E is going to equal 36. I can write it. And then in order to find F is going to have to be 12 square roots of 3, because that's what D was, times 2. So 12 times 2 is 24 square roots of 3. Remember, outside times outside, inside times inside. So for this triangle, we had D is equal to D, but D times the square root of 3 is equal to E, and D times 2 is equal to F. So you can solve and use whichever one you need. And it'll always be that way with these things in it. The D's, the E's, and the F's may change to some other letter, but it's always going to be the same. And over here we had C is equal to A times the square root of 2, and A is equal to B, because they're the same. So as long as you know those four, you should be fine for what the classwork and homework is today. And I'm saying the hard part of today is memorizing those orders. It's not very much to memorize, but it works exactly the same way as Pythagorean triples did in the last section. So there is no classwork today because I just worked out 4 problems, and that should be enough for classwork, which leads us to the homework for today. It is located on page 324. It is numbers 5, 7, 13, and 15. And that's it for today. Have a wonderful day. And once you're done, well, have a wonderful day once you're done with this. The next section that we do is going to be the last section in this chapter, and then you're going to have a review, and then you're going to have a test. So make sure you get all this stuff memorized that I've said you need to memorize. Okay, bye.